Euclid Book 3, proposition number 1 is incredibly simple. First of all, Euclid has you draw a circle just like this, and I drew a great big one so I could draw the rest of this, alright? So anyway, let me get that little cord out of there. Alright, then Euclid wants you to draw a line. It's called AB, and point A touches one portion of the circumference of the circle, the other point B touches another point on the circumference of the circle, so any line that has 2 points touching the circumference of the circle, which this is point A, this is point B, this touches one part of the circumference of the circle, this one touches the other part of the circumference of the circle. Draw this line here, and then what you're going to do is you're going to bisect this line at point D. Now you should know how to do this because of Euclid Book 1 propositions 10 and 11. Okay, so you have to go back to that to find out how to bisect line AB. Once you find out how to bisect line AB, you're going to draw another line. And it's going to go from point E all the way through point D and all the way up to point C. So you're going to have CDE. Okay, and CDE is perpendicular to AB. And you should know this by Euclid Book 1 propositions 10 and 11. Alright, and then you're going to go one more step and you're going to bisect line CE. And where it's bisected is at point F. And Euclid says that this point F is the center of circle ACB. Okay, ACB. Now how do we know this? Well, Euclid says, let's just suppose that point F was not the center of ACB, but rather point G was the center. Okay? Then he goes on to say that we already know that AD and DB are equal in length. Okay, we know that. And we can justify that because of Euclid Book 1 propositions 10 and 11. Okay? We already know that line GD is equal to itself. Okay, so now we got an angle here and an angle, not an angle, but we got a line here and a line here. This line is equal to itself. This line is equal to this line. So that means the two sides of a circle are equal to each other. Now he goes on to say that because we have established that point G is the center of the circle, then that must mean that AG and GB are equal in length. Right like that. Okay? Now, later on we're going to find out that's not true, but just hypothetically we're saying that line GA and GB are equal in length. Well, if that's true, then we find out that all three of the sides of this triangle, which was ADG, is the same size as all three sides of triangle GDB. So ADG and GDB are equal in size, according to him. Now, if that's true, then angle ADG is also equal to DGB. And if that's true, then by Euclid Book 1 Book 1 definition 10, then ADG and DGB are right angles. But then we get into a little problem, because now we can say truthfully that angle FDB is a right angle. Now if FDB is a right angle and GDB is a right angle, then FDB and GDB have to be the same amount of degrees, and they're not. So therefore, point G is not the center of the circle, but rather point F. And that's what Euclid was trying to prove. Alright, well now you know how to find the center of a circle. I will tell you more in the next video, so stay tuned.